Yo, 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 Unit 6, Energy Resources and Consumption Review. Whoa, whoa, whoa. Number 1, compare a non-renewable to a renewable energy source. So we're going to be talking about renewable first, and I'm going to write my answer up here. Renewable. So renewable is defined as anything that is generated from a natural source that can be replaced over a relatively short period of time. Non-renewable comes from resources that are not replaced or are replaced only very slowly by natural processes. Number 2, identify 3 examples of renewable resources and 3 examples of non-renewable resources. So again, let's go start off with renewable. Number 1, we have solar. Number 2, wind. Number 3, hydro. And I'm going to write down geothermal, because we tend to forget about that. But other ones would be hydroelectric as well as biomass. Then we have non-renewable. Number 1, coal. Number 2, oil. Number 3, natural gas. Number 3, how do developed and developing countries compare when it comes to energy consumption? Why? So let's write out our answer here, y'all. Number 3. Number 3. And this is a general trend. A person living in a developed country which has a higher or a highly developed economy will consume more energy than a person living in a developing country. That is non-industrial and poor. The economy of a developing country improves the energy consumption for that country rises. Number 4, What type of country uses more fossil fuel and why? So it would be the developed countries. Because it is less available and more expensive compared to using biomass. And biomass is plentiful and inexpensive. Okay, number 5. Does industrialization lead to high energy consumption rates? Why not? So, industrialization leads to high energy consumption because of the increase demand to run factories and keep up with demand. Why is wood fuel commonly used in developing countries? So wood is commonly used because it's widely available and it is cheap. Number 7. What are some environmental concerns with using wood as an energy source? So the concern would be deforestation, from the inability to replant as quickly as the trees are being used. Also, carbon dioxide release, which contributes to global climate change. Number 8, in the box to the right, list the ranks of coal in order from highest to lowest energy content. So I'm going to write down all the different types. First, we have lignite, subbituminous, bituminous, and then anthracite. So formation conditions, we have low temperature, pressure, and then going over to this side, high temperature, pressure. Okay, and then time formation. Lignite being taking the fewest, and then we have low energy content, and then high energy content. And we can also list the percent of carbon. There we go. Number 9, list 3 air pollutants that are emitted during the burning of coal. So the 3 air pollutants would be sulfur dioxide. We also have carbon dioxide. And last but not least, mercury. 10. List 3 sources of methane that are amplified by human activities. So, animal agriculture. Remember, those cows' digestive systems. Again, breaking down those food creates that methane. Landfills, anaerobic decomposition. Again, without that oxygen, creates methane. Biomass burning also produces methane. Okay, so how is methane produced or naturally produced? So methane is produced during anaerobic bacterial decomposition. 12. What is released when natural gas is burned, thus making it the cleanest fossil fuel? So 60% as much CO2 as coal. Boom. 13. Place the following 8 events in chronological order. The oil spill of Exxon Valdez, the meltdown of the reactor at Chernobyl, the discovery of contamination in Love Canal, the first Earth Day, the leak of methyl isocyanate in Bipol, the drafting of the Kyoto Protocol, the ratification of the Montreal Protocol, and the passage of the U.S. Endangered Species Act. So, boom. Let's start off with A, Earth Day. And Earth Day occurred in 1970. B, the Endangered Species Act. 1973. Then Love Canal, 1978. Montreal Protocol, 1983. Chernobyl, 1986. Exxon Valdez, 1989. And then the Kyoto Protocol, 1997. Okay, 14. Strengthen this weak statement. Fossil fuel use releases carbon dioxide, which causes the greenhouse effect. So burning fossil fuels releases carbon that was sequestered underground, adding to the net greenhouse content of the atmosphere, which causes increased rates of global climate change. So that's the stronger statement. So again, burning fossil fuel releases carbon that was sequestered underground, adding to the net greenhouse gas content of the atmosphere, which causes the increased rates of global climate change. Okay, number 15. I'm going to list 15 just right here because I don't have room. So 15, list 4 products that are derived primarily from crude oil. So we have asphalt, gasoline, heating oil, and jet fuel, and diesel oil. One for good measure. Okay, so we have 16. The acronym OPEC refers to the Organization of Petroleum Exporting Countries, and is important because it's made up of 13 countries that have 60% of the world's proven crude oil, and thereby likely to run the world's oil supply for decades. Official purpose is to coordinate and unify petroleum policies, create stable markets. So official purpose equals coordinate and unify petroleum policies and create stable markets. I'm going to write 17 here. Explain what the Deepwater Horizon was, where it went, and why it is significant. So, it was the largest marine oil spill caused by an explosion on the Deepwater Horizon rig. The environmental impact was unprecedented, with 140 million gallons being leaked into the Gulf of Mexico. Okay, 18. So I guess I can write it there. The acronym ANWR refers to the Arctic, the Arctic National Wildlife Refuge, and it's important because it contains a large reserve of oil, which has been a topic of debate for decades. 19, the acronym CAFE refers to the corporate average fuel economy. And it's important because, and I'm going to continue 19 down here, it's important because its objective is to improve fuel economy for all the vehicles produced in the US. Well, I didn't get to do 20 on the previous slide, so I'm going to do 20 now. So 20 is compare a tar sand to shale oil, or some environmental concerns of each of these. So oil, shale, is a form of sedimentary rock that contains kerogen, which is released as a petroleum-like liquid when the rock is heated. Tar sands are a combination of clay, sand, water, and bitumen, which is a heavy hydrocarbon. So tar sand oil uses a large amount of water and produces an enormous amount of greenhouse gases. The net energy retrieval is very low compared to oil shells. Tar sands require a lot of deforestation. Number 21, what is cogeneration and why does this process increase efficiency? Okay, so it is the generation of electricity and other energy jointly, especially the utilization of the steam left over from electricity generation to produce heat. For each energy source, identify what country contains the largest amount of the energy source. Coal, China. Crude oil, USA. Natural gas, USA. USA. Uranium 235 USA. Geothermal USA. What up? So 23. Describe how fossil fuels are ignited and converted into electricity. So I'm going to write 23 down right here. The fossil fuels are burned, to heat water, the steam from the water then turns the turbine. The turbine is used to rotate a magnet encased in the generator at high speeds. As the magnet spins, electrons are produced, and they power the electricity grid. How to, or I guess the question is, how do wind, geothermal, and hydroelectric work? So let's start off with wind. So with wind energy, wind turns the propeller, like blades, of a turbine around a rotor, which then spins a generator which creates electricity. I'm going to write geothermal here. So geothermal taps into steam or hot water reservoir underground the heat is used to drive the generator. And then I'm going to do 24 with hydroelectric. So hydroelectric, let's start up here. Captures the energy of falling water to generate electricity. Turbine converts the kinetic energy of falling water into mechanical energy. generator converts the mechanical energy into electrical. Fracking is short for hydraulic fracturing, and is a concern because it contaminates ground water. It releases methane and uses massive amounts of water. Number 26. How does fracking pollute the groundwater? Leakage from storage, wow, okay. Injection wells, and then along faults. Compare a fuel rod to a control rod. How do they work together? So a fuel rod, I'm going to write down here in the open space, fuel rods contain the fuel that fission and heats the water. The control rods are used within fuel rods to control reactivity, absorbing the excess neutrons specifically. Number 28. So we have state where Chernobyl is located and explain what happened there. So Chernobyl is located in the former USSR, now Ukraine, and there was a nuclear meltdown there. It is still closed and in exclusion zone today. 29. Explain what happened at the 3 Mile Island and why it's significant. So, 3 Mile Island is in the US and the reactor partially melted down, but only minimal radiation escaped the containment unit. So 30, explain how thermal pollution is produced by power plants. Okay, so we have most power plants have large amounts of heat produced to turn water into steam, which turns a turbine which is connected to a generator. So the steam is condensed and recycled using cooler water. This heated water is returned to a nearby river or stream, which can cause thermal shock to organisms. So let's finish that out. The steam is then condensed and recycled using cooler water. This heated water is returned to a nearby river or stream, which can cause thermal shock to organisms living in the lake. Okay, 31. Explain what happened at Fukushima and Daiichi and why it's significant. So, it occurred in 2011 when a tsunami hit the nuclear power plant. Meltdowns occurred, and 3 out of the 6 reactors, no fatalities or radiation sickness was reported. A radioactive cloud may contain iodine-131, which has a half-life of 8 days. If the waste must decay to a concentration of less than 0.1% to be considered safe, it will take approximately blank days to reach safe levels. So in order to start this, y'all, a percentage, y'all, we're always going to start off with 100%. A half-life simply means that it decreased by half. So I divide by 2, that's 1 half-life. That gives me 50. I divide by 2 again. I need to get to 0.1%. So that's 2 half-lives, y'all, to get me 25. Divided by 2, 3 half-lives. I'm circling each value there. So I have 12.5, then divided by 2, we have 4 half-lives. Gives me 6.25 divided by 2. Gives me 3.13 divided by 2. Sorry. Gets me 1.56 divided by 2. I'm not there yet, y'all. 0.1%. 7 half-lives there, so 0.78 divided by 2 gets me, again, 0.39 divided by 2 gets me 0.195 and I divide it by 2 one more time. That's a total of 10 half-lives, y'all, to get 0.0975% of the mass. So now I know that it takes 10 half-lives, so 10 half-lives, okay, multiplied by 8 days to 1 half-life. That cancels out, and I'm left with days. So it takes 80 days, y'all, 80 days for it to be considered safe. What is biomass and how it's converted into an energy source? So biomass, writing right here, y'all, organic matter used as fuel. Solid biomass, such as wood and garbage, can be burned directly to produce heat. So what is biogas and how it's converted to energy? So biogas is a type of biofuel that is naturally produced from the decomposition of organic waste. In most cases, biogas is used as fuel for combustion engines, which convert it into mechanical energy powering an electrical or electric generator to produce electricity. In the box to the right, sketch a house and the surroundings of a house that is designed to make the greatest use of passive solar energy in the Northern Hemisphere. Include inside the box the location of both the winter and summer sun and labels to indicate the compass direction that the house faces. So I'm going to draw a simple house here. A chimney, the roof, it has some opening here. So an opening to allow the sun to come in. Okay, and so that's the house with the roof and the sun during winter. So it's a low winter sun. So the sun heats up the house, and then we have the house when it's the summertime. Again, Mr. Tran is not an artist, so bear with him. Again, with the sun located higher up, the heat is not reaching the windows there. And so this is the high summer sun. Okay, so let's move on. It says compare passive and active solar energy. So there are two ways to harness the energy of the sun. Passive systems are structures whose design, placement, or materials optimize the use of heat or light directly from the sun. Active systems have devices to convert the sun's energy into a more usable form, such as hot water or electricity. Okay, perform the following calculations. A 40 square meter solar array is installed on a house where the average installation is 6 kilowatt hour per square meter per day. If the average total electricity output of the array is 1.2 kilowatt hour per hour, the efficiency of the array is. So let's start off with the number that's given to us. I'm going to write 37 right here, y'all. We have 40 square meters. Okay, and then we're going to multiply it by the 6 kilowatt hour per square meter, and then per day. That actually gets this to cancel out, and then this equals 240 kilowatt hour per day. And I can take this per day and change it into hours. Okay, so we have 1 day, 24 hours. Day cancel out, essentially dividing it and get 10 kilowatt hour per hour. So now I can take my kilowatt hour and divide it. So 1.2 kilowatt hour per hour, and I divide it by 10 kilowatt hour per hour to get the efficiency is 0.12. Change it into percent, 12%. 38. List 3 species that may be threatened by the construction of a solar power tower in the California desert. So, first up, the desert tortoise. Second is the mountain yellow-legged frog. And then finally, Joshua tree. Silicon is the active element in most photovoltaic cells. How do PV cells work? So I'm going to write it up here, y'all. Solar P photovoltaic cells generate electricity by absorbing sunlight. Using the sunlight to create an electrical current. There are many PV cells within a single solar panel. And the current created by all of the cells together adds up to enough electricity to help power your house. Number 40, compare off-grid to on-grid solar systems. So I'm going to write 40 down here. Let's start off with a home. Solar panel system could be installed either as a standalone system or a grid connected system. They are also referred to as off-grid systems or on-grid system. A grid connected or on-grid system is a solar panel system that works with or is connected with a utility grid. Okay, we have 41. Arrange the following types of electromagnetic radiation in order of from lowest to highest energy. So, lowest to highest would be radio, microwave, infrared, visible, ultraviolet, X-ray, and then gamma. List the following types of visible light in order from shortest to longest wavelength. Okay. So we have violet, blue, cyan, green, yellow, orange, and then red. In the box to the right, draw a diagram that illustrates how electricity is produced by a dam. So, boom, we have the dam here. Right here is the water, or the reservoir. And then we have the intake area. So with the intake area, it leads into an area that has a turbine. Okay, and that turbine is connected to a generator. Okay, and that generator is connected to the grid. Okay, and then the water continues to flow out. To a river. So that's how that works. Bad drawing, but you know, good enough, I say. Good enough. Okay, so this whole thing is the dam. Okay. Number 44. So, how is geothermal energy generated? Geothermal power plants use steam to produce electricity. The steam comes from reservoirs of hot water found a few miles or more below the surface of the earth. The steam rotates a turbine that activates a generator which produces electricity. Describe the basic components of a fuel cell. What are the limitations of fuel cells? What are the advantages of fuel cells? So, I'm gonna be writing it right here, y'all. 45. So, fuel cell works by passing hydrogen through the anode of of a fuel cell, and oxygen through the cathode. At the anode site, the hydrogen molecule are split into electrons and protons. So we have limitations. Expensive. While widely available, hydrogen is definitely expensive. It's difficult to store. Hydrogen is very hard to move around. Highly flammable. Dependent on fossil fuel. Advantages. Cleaner. Reduce greenhouse gas emissions. Hydrogen is abundant. How does wind turbine work? What are the limitations of wind turbines? What are the advantages of wind turbines? So, wind turns the propeller like blades of a turbine around a rotor, which spins a generator, which creates electricity. So I'm going to start off up here with limitations. So noise pollution, interferes with bird migration, and then advantages. Low cost, efficient use of space. And then 47 lists 4 things you could do to conserve energy. So I'm going to start off right here with number 1. Use Energy Star appliances. Number 2, switch to LED lights. Number 3, walk, bike, carpool. Number 4, double paned windows. If the cost of gas is $3.50 per gallon and the average gas mileage of a car is 25 miles per gallon, the cost of driving the car per mile is blank dollars per mile or cents per mile. Okay, so let's show our work. We start off with 3 $2.50, and we know that this is per 1 gallon. We know that our car takes 25 miles per gallon. So gallons cancel out. I basically divide, and I get 14 cents per mile. So $14. Okay. So this now is all about the math. A family, and I'm going to be showing my work as I can. So a family has a total of 1,500 watts of light bulbs throughout their house. If they replace them all with LED light bulbs, which use 90% less energy, the family will now use blank watts of electricity. And so in order to calculate that, y'all, we simply take the 1,500 watts, we multiply it by 0.10, because it uses 90% less, so it only uses 0.1 or 10%. So when we multiply that, we get 150 watts. Okay, B, a space heater operates at 1,500 watts if it used for 10 hours each day for 1 week, and the cost of electricity is 20 cents per kilowatt hour. It will cost blank to operate. So first I need to get the kilowatt hour unit. So I take 1,500 watts times the amount of hours used, which is 10 hours, and then I can multiply it by the 1 per kilowatt, and then divided by 1,000 watts. So that cancels out, and I am in kilowatt hours, and now I multiply it by 20 cents, and I get the cost of around $3 per day, because it's 20 cents per day. And then I want to get rid of that to get, in a week. So that's 7 days on top per 1 week. And it cost me $21 to operate for 1 week. So 21. Okay, C, we have a 60-watt light bulb that is used for an average of 4 hours each day, uses blank kilowatt hours of electricity per year. So same concept, y'all. Take the watts, multiply by the hour. So I get 240 watt hour. Well, I want to convert it into kilowatts, so 1 kilowatt on top per 1,000 watts. Watts cancels out, and now I get 0.240 kilowatt hour, and this is per day because we use it per day here. So now I have per day. I can convert it into years, so 365 days. Okay. Per 1 year, days cancel out, multiplying at 87.6 kilowatt hour per year. So 87.6. Okay, y'all, that's it for today. Have a good one.